Molecules and compounds, a focus on chemical compounds. In this tutorial, we will be going over an overview of ionic compounds, writing and naming ionic compounds, an overview of molecular compounds, writing and naming molecular compounds, and finally, names and formulas of acids. Content you are responsible to know: the difference between ionic bonds and covalent bonds, being able to differentiate between empirical, molecular, and structural formulas, differentiating between molecular and ionic compounds, using your understanding of writing chemical formulas, be able to write chemical equations, which we'll talk a lot about in the future, and understand the difference between reactants and products. So these are the things that you should be able to do by the end of this chapter of your book. Ionic compounds. Ions are referred to as charged particles. Cations specifically are referred to as positively charged particles, and an example of that might be something like a sodium ion or a strontium ion, Sr+2. Anions, on the other hand, are referred to as negatively charged particles, and an example of that might be the chloride ion, Cl-1, or the nitride ion, N-3. Summarizing ionic compound formulas. Ionic compounds always contain positive and negative ions. In a neutral chemical compound, the sum of the charges of the positive ions must equal the sum of the charges of the negative ions. The formula of an ionic compound typically reflects the smallest whole number ratio of ions. There are exceptions to the rules here. Write the formulas for the compounds formed by the following ions. I'm going to do the first one, and then I'd like you to stop and attempt to do the next two, start the video again, and check your work. So I have Na+1, PO4 -3. So what I'm going to do here is basically a review of the crisscross rule. So the +1 is going to go down here, the -3 is going to go down here, but remember, when you are writing a formula, no positives, no negatives, no ones. So when I cross this down, it's going to be Na. I'm going to have a subscripted 3 from the phosphate ion, and then PO4. I'm not going to bring down the plus or the 1. Another way of looking at this is also thinking, well, phosphate has a charge of -3. In order to neutralize that, I need 3 sodium ions, so that's where this 3 is coming from right here. Now what I'd like you to do is stop, write the formulas for the next two, and then check your work. Welcome back. Let's see how you did. Zn+2 SO4 -2. Here it's pretty easy. You can recognize that we have a +2 and a -2, and they're automatically going to cancel each other out. So we're just going to have ZnSO4. No need to cross down because the +2 and the -2, again, will just cancel each other out. Fe+3, CO3 -2. In this case, we are going to cross these down. So the 2 is going to be subscripted by the Fe. The 3 is going to be subscripted by the CO3. Now remember, it's very key that you remember to put brackets around the CO3 because you don't want it to look like CO33. That would just be bizarre. So we're going to have Fe with a subscript of 2 and then parentheses CO3 with an N subscript of 3. And that is how you write the neutral formula for Fe2CO33. Write the chemical names for the following binary ionic compounds. Now this should be a big review from your summer assignment, so I'm not going to provide much help here. So if we look at the first one, NaCl, I know that the Na is sodium. I know that the Cl is chlorine, so I'm going to change that ending to "ide." So for the first one, it's going to be sodium chloride. So again, what I'd like you to do is stop, write the names for the rest of these, and then continue with the video to check your work. Welcome back. Let's see how you did. So SRO, you should have written strontium oxide. ALN, you should have written aluminum nitride. BaCl2, you should have written barium chloride. K2O is potassium oxide. CuO is copper 2 oxide. We needed a Roman numeral for that one because remember, oxygen is -2, so that means the Cu has to be +2. Copper is a transition metal. We'll get into reviewing that a little bit more in a second, but we need that Roman numeral here because if we compare that to the next one, Cu2O, that is copper 1 oxide because again, oxygen is -2. So that 2 is down there, which means this has to be +1. So I need 2 of these copper +1 ions to make neutral the O-2. Write the chemical formulas for the following chemical names. Ammonium nitrate. You should know that ammonium is our positive ion here because it's listed first, and that is going to be NH4 +1, and the negative ion for nitrate is going to be NO3 -1. These are polyatomics that you should have memorized over the summer. So NH4 +1, NO3 -1s, the ones will cancel out. This is going to be NH4NO3. Copper 2 bromide. The positive ion here will be our metal. The Roman numeral tells us that it's going to have a charge of +2. So this is going to be Cu +2. The bromide is going to be Br -1. So when I cross these down, it's going to be CuBr2. Copper 1 bromide. The positive ion here is Cu +1. The bromide is going to be Br -1. So the +1 and the -1 are going to cancel each other out. So that's going to be CuBr. Let's look at the next one. Zinc hydrogen sulfate. Only the zinc here will be my positive ion. And I know that positive ion for zinc is Zn +2. The hydrogen sulfate is a polyatomic ion that you should know, and that is HSO4 -1. So I have +2 and -1. I'm going to cross these down. No positives, no negatives, no ones. So my formula here is going to be ZnHSO4 with a subscripted 2 to make this compound neutral. Aluminum sulfate. The positive ion is going to be Al +3. Sulfate is SO4 -2. I'm going to cross these down. So the formula here will be Al2SO4, need parentheses around this, and then a subscripted 3. Sodium perchlorate. Sodium is Na+1. Perchlorate is ClO4 -1, another polyatomic that you should be familiar with. The +1 and the -1 will cancel each other out because no positives, no negatives, no ones. So this is going to be NaClO4. Copper 2 iodide. All right. Copper Cu +2. The negative ion is going to be IO2 -1. We're going to cross these down. So the final formula here will be CuIO2. And this should be enough examples to remind you of what you should already know about writing formulas that contain polyatomic ions, that contain parentheses, making sure that these compounds are electrically neutral. Names and formulas of binary molecular compounds. Basic concepts to remember. The name of the element farther to the left on the periodic table is usually written first. The exception here is oxygen, which is always written last, with the exception of fluorine. The name of the second element is given an IDE ending, because again, we're dealing with binary molecular compounds. Prefixes are used to indicate the number of atoms of each element, and compounds containing hydrogens are exceptions. We'll talk about that in a minute. So remember here, we're dealing with molecular compounds, so that means we're dealing with non-metals, so we have a different way of writing these names. Name the following binary molecular compounds. So let's look at the first example. Dinitrogen tetroxide. Okay, the di and the tetra are basically telling you how many of these elements we have here. So if I was to write the name of this, this would be N2O4 for dinitrogen tetroxide. If we look at the example, again, we have N2O5. So the difference here is the 5 is going to be a pent. So we're going to have the same beginning as we see up here. So this is going to be dinitrogen pentoxide. And you could write it pentaoxide, but a lot of times we just sort of blur it together. Remember, the last element is going to have that IDE ending, but the first element we're just going to leave as is. So what I'd like you to do is stop. Write either the name of the compound or the formula for the last 3 and see how you do. Welcome back. Let's check your work. PCl3. To name that should have been phosphorus trichloride. Because we only have one phosphorus up here, we're just going to name the element name. And then trichloride comes from the 3 chlorines at the end. Phosphorus pentachloride would have the formula PCl5. And finally, SF6 should be sulfur hexafluoride. And that's a little review of how to name binary molecular compounds. Names and formulas of acids. An acid is a substance whose molecules yield hydrogen ions when dissolved in water. And we'll get into acids in much more detail in the future, but we're just going to look at a basic definition right now. When identifying an acid in a chemical equation, the formula should be accompanied by an aqueous symbol, AQ. So there is a difference between the two following compounds. H2S without the AQ is just hydrogen sulfide because there's no aqueous symbol present. But if I put that little AQ subscripted right here, now I have hydrosulfuric acid because that aqueous symbol is present. So you really need to look at whether your compound has the AQ or not. And I really should have a subscripted something right here, but I'm just going for the difference of with or without the AQ for right now. So let's look at this first one, HF. No AQ. So when we name that, that would just be hydrogen fluoride. As soon as we say it's AQ, that this hydrogen fluoride is now dissolved in water, we are now dealing with an acid. And the name of this now will be hydrofluoric acid. H2SO4. This is hydrogen sulfate by itself, not in an aqueous environment. But again, as soon as we put that AQ on and we're saying, well, we have this H2SO4 in an aqueous environment, now the name switches to sulfuric acid. So you really need to pay attention to whether the AQ is present or absent. Key points to remember. H is written as the first element. Acids are composed of an anion, a negatively charged particle, connected to enough hydrogen ions to balance the charge. So for example, here's my carbonate ion. It has a charge of -2. So it needs 2 hydrogen ions to balance the charge and form H2CO3. The phosphate ion has a charge of -3. It's going to need 3 hydrogen ions to balance the charge and form a neutral compound of H3PO4. More key points to remember. Acids containing anions whose names end in IDE are named by changing the "ide" to "ic" and adding the prefix hydro to this anion name. We're going to follow with the word acid at the end. So HBr, aqueous, we know that the anion here, the negatively charged particle, is going to be Br-1. So the acid name here would be hydrobromic acid. For HI in an aqueous solution, the anion is I-1, and the acid here would be hydroiodic acid. H2S, the anion here is S-2, that's sulfide ion, and that's going to be hydrosulfuric acid. And finally, HCN, aqueous. The anion here is going to be our cyanide ion, Cn-1, and the acid name here is cyanic acid. So some examples of how to name acids. Acids containing anions whose names end in ATE or ITE are named by changing 8 to IC, to us, and adding the word acid at the end. These are commonly known as oxyacids because they have oxygens in their compounds. So let's look at some examples here. HNO3, you should be familiar with this acid already. The polyatomic ion here is the nitrate ion, that is the NO3 minus 1, and the acid here, because we are ending in 8, will turn into ic, 8 to ic, so nitric acid. HNO2, the polyatomic ion here is nitrite, that's NO2 minus 1, so we're going to change the ite to us. So HNO2 in an aqueous solution would be nitrous acid. H2SO4, the polyatomic ion here is sulfate, so we're back to that 8 situation. So like we did in this example up here, we're going to change 8 to ic. So this is going to be sulfuric acid. And finally, H2SO3, the polyatomic ion here will be the sulfite ion, SO3. So the acid here, because we're dealing with that ite ending, will be sulfurous acid. There are some anomalies in this system when dealing with the halogens. An example of this can be seen in naming system of polyatomics of chlorine. So the polyatomic ions I have listed here, we're going to go over the names of the polyatomics and see how the acids work out. So ClO4 minus 1, that's perchlorate. That's the name of the polyatomic. So we're having that ending of 8. So when we put this in an aqueous solution with all of these neutralized by hydrogen, this is going to be perchloric acid, and we see that 8 to ic ending. ClO3 minus 1, that's chlorate. So here we still have 8. That means that we're going to change our ending to ic. So that's just chloric acid. The only difference between these two is an extra oxygen up here, which means we have that per. ClO2 minus 1 is chlorite, so that's going to be chlorous acid. ClO minus 1 is going to be hypochlorite for the name of that polyatomic. We still have that ite ending, so the acid here is going to be hypochlorous. We just kept the hypo there, so ite to us. And finally, Cl minus 1 is going to be chloride. We've already done this one, and that's going to be hydrochloric acid. The same type of format also applies to bromine and iodine. Name the following acids. HBrO3, so the polyatomic ion here is going to be our BrO3 minus 1, and our acid is going to be bromic acid. HC2H3O2, the polyatomic ion here is our acetate ion, so C2H3O2 minus 1. So the acetate ion, this is where we start getting into a little bit of the organic acids. So the acid name here is acetic acid. HiO3, the polyatomic ion, is going to be IO3 minus 1. And the acid here is going to be iodic acid. So you need to be able to look at the polyatomics and figure out the acid name. So what did you learn? We did an overview of ionic compounds. We looked at writing and naming ionic compounds, an overview of molecular compounds, writing and naming molecular compounds, and then finally we did a big review of naming and formulas of acids. Need more help? Feel free to contact me. Have a great day.